I want to run through this GPS tracker system. It's not really a product review per se. I'm not trying to put it up and see how it works or assess that. What I want to look at is actually the board, and I've opened I bought two of these before, and if you look inside, it comes with a little unit, more these little pull things, some cords, antenna for one thing, antenna for our next. There's two antennas on it, and auto relay. So yeah, fuse plug in here and a fuse. So right, it's not a bad system at all. It's a pretty decent system. I bought this about probably 2 years ago, if I remember correctly. It's around 38 US I paid for it. Bought two of them, never installed any. So we're gonna strip only one of this. Has been opened and sitting down. It's a nice little magnetic clamp box. So that's this one. As I said, two antennas, one for the GSM modem and one for the GPS itself. Jack here, can't recall what that is for. Micro USB port, SD card, the SIM clip, which you just press and it comes out. A little more one hand. Damn. Anyway, this is a clip to put in the SIM. In the back here is a connector for the wiring. Another connector here, LED, and an on-off button. So nothing too fancy. And this looks like a standard extrusion, and they've basically cut two front plates on it. An excellent extrusion actually. I really like this extrusion. It's a really nice project box finish, C markings. What I really want to do is open it and get into how they did this board. And what amazed me with how they did this board, I've done something very similar, and how they have managed to actually implement their solution, it's quite interesting actually. So that's what I want to do, document it and just have a look inside, see how they put together, what's good, what's bad, how it looks. Now it's open and you can see simple extrusion. This is the back plate here, really nice for screw holes, so 4 screws there to get in, two antennas, a small LiPo battery that is stuck on with double-sided tape. This is the core of it all. This Kuban, this would be a GSM modem. This is most likely a power regulator, might be a buck or boost, I don't know for sure. Actually it should be, this is 3.8, can't tell for sure. This normally runs on at 3.3 volts, so it may be a buck, but an inductor with it, so definitely a buck or boost converter. A little NC8772P, I'm not sure exactly what this is. On our switch, as you said, all surface mount components, looks like diodes there. Yeah, they're all, board is pretty well labeled if you look at it, reasonably well labeled. Let me get the other screwdriver. So everything, cell screen is pretty good, decent connections. Looks like a light gold plating on this. This is the SD card connection. So let's turn to the other side. Right, this here, this here is a GPS, clearly states GPS, and again all surface mount components, very neat layout. If you look at this, extremely neat layout, very well done, no complaints here. These are one of the more expensive SD card connectors. I have to press this. Let me see if I can press this with one hand. Right, this comes out, full size SD card. You put it in the tray, plug it back in. So yeah, in terms of layout, brilliant, can't complain. GPS here, GSM modem here. So now the question is, where is the microcontroller? And this is the brilliant part. This is what I want to document on this. They have managed to get internal access to the processor in this. This is a full processor, a full board in here. This is not really just a simple modem. That's a full chip. Normally this is done, communication, this is done with what you call AT commands, attention commands, are sent from a microcontroller onto this. This executes the function and then returns to the microcontroller some sort of confirmation. Each manufacturer has its set of commands, and there's a full data sheet normally, and you know what you send, and you get a send a signal, you get a response that yes, everything's active, yes, connected to the network, all these things. They have managed to get an ability to program in the whole thing where you can set the numbers, where you can set the information, where it sends the GPS, it reads that GPS information on the other chip, and then takes it and sends it out to the to the user who's requesting. This security system, I did mention before, what it is based upon is you plug it in into your car, you hide it somewhere, it can shut off, it has the ability to activate that relay, and that allows it to shut off things, right? So basically it can shut off, and they recommend to shut off your oil pump, which really doesn't make sense to me. If you shut off your oil pump, you probably mash up the car. Anyway, you can send in a code and shut off something to shut down the car. You can use this, send a text to it, and it will return and tell you where the vehicle is, right? Give you the GPS coordinates, and from there obviously you plot it on a map and you know where the car is. This is the list, the output in the GPU, right? This is basically your output here, and you are able to control things. Normally that requires a micro, right? You normally have a micro, and you'd have transistors to be able to have the relevant amount of power, and they've managed to do all of that on this Kuban CE2200. Actually it's a CB900. That is that's another number, that's the C number, and that's the FCC ID. And that's the brilliant thing about these chips too, they come with FCC ID, so you don't have to go through all the trouble of actually trying to get any of these things passed in any area. So yeah, it's a CB900. I've looked at this chip actually when I was designing the other board, which I will review shortly enough. And I chose to use Simcom chips, and partly because they had Bluetooth incorporated, so it was a GSM and Bluetooth chip, and that was an old chip, it was a Gen 2 chip, so it's no longer applicable in many jurisdictions. But this is really brilliant. These things come on the board like that, and you just solder them on, and the fact that they were able to get their whole programming that allows it to read the other side, execute functions, execute the switching on and off within that manufactured chip, that has dropped the cost a bit. Again, as I said, this is 38 US if I retail. Just a LiPo battery, converters, these Molex connectors are enormously expensive. It is really amusing that something like this can cost you $2 US, right? Whereas a chip, like a GPS chip, could end up costing similar amount. The Simcom I used was 8 US. I don't know exactly how much this GPS chip is, I haven't checked, but this little B tends to be 1 or 2 US, 250 might be. So this little chip B is probably more than a micro. It's gonna cost more than, let's say, use Atmega 328P. That's gonna cost more than that. But just documenting what these guys have done. I'm gonna take a few pictures and put some still shots at the end, just keep it so I look back on it later on and say, great work, brilliant. I cannot understand how they could sell this for 38. It really is in mass production, and you're really looking at 10,000 plus items to get that kind of orders of magnitude, lower price. These are extremely expensive. Those connectors are extremely expensive. These are quite expensive, $1 or $2 US a piece. When you put it all up, this is more than $38 in parts. If I'm buying for 20, 50 or 100, I have more than 38 US in parts here. We're not talking board fabrication, we're not talking assembly, we're talking just bare bone parts here. It's more than 38 US. It really is amazing. Mass production, you really get good products as customers for low value.